evening, everyone. Today we will present about titanium trichloride as a catalyst.
Okay, so for the first subtopic, which is properties of titanium trichloride. First, the molar mass is 154.225 gram per mole, and the second one is melting point, which is 425 Celsius, and the boiling point is 960 Celsius. The titanium trichloride also soluble in water, acetone, acetonitrile, and certain amines. And the last one is it insoluble in ether and hydrocarbons. So we will move for the second subtopic, which is how titanium trichloride was formed. So titanium trichloride is produced usually by reduction of titanium tetrachloride. So as you can see, this is the chemical equation. The 2 titanium tetrachloride plus gas hydrogen will produce 2 acid hydrochloric and also 2 titanium trichloride. So this is how the titanium trichloride was formed. So is there any question or you guys don't understand about this subtopic?
NAUFAL, can you please explain more about the chemical equation when titanium trichloride is formed?
Okay, so thank you, ALIA, for your question. So I will elaborate more about how titanium trichloride was formed. So the process is the oxidation reduction process. As you can see in this equation, the titanium trichloride is formed by reduction of titanium tetrachloride. So the titanium tetrachloride undergoes reduction process and become the 2 titanium trichloride, and it gains electron from gas hydrogen. So the gas hydrogen undergoes oxidation process. So and then it will become 2HCl, which is acid hydrochloric. So I hope that it will answer your question. So let us let us move to the next subtopic. I will pass to Putri Shah.
So now I'm going to proceed to the structure of titanium trichloride. So as you can see, at the right side is the view of titanium trichloride along the chain. So the structure of titanium trichloride is that each titanium atom has 1d electron. So rendering its derivative paramagnetic, the substance is attracted into a magnetic field. So all feature titanium in an octahedral coordination sphere. Okay. So this form can be distinguished by crystallography as well as by their magnetic properties, which proves exchange interactions. So the titanium trichloride, the crystallized shape is in brown needles. So its structure consists of chains of their distance short and indicate strong metal-metal interactions. That's all for me. Any questions?
Shah, I wanna ask, what's the color of TiCl3?
Okay, so the color of titanium trichloride is purple. It is known for their purple solution. The low pressure gas phase process that will be presented by SHENG.
Okay, thank you, Shah. So I will be sharing screen as the picture is in the poster is quite small. Can you guys see my presentation? Okay.
Yes.
Okay, so I'm going to start with the manufacture of polyethylene, or we call polyethylene. We got the Ziegler-Natta catalyst, right? Which involves the TiCl3 as one of its components. We'll be going to use the catalyst. It's quite a important compound when we are going to carry out this kind of process. So there are actually 3 processes they are actually separated, not one whole process. So we are going to start with the slurry process. So as you can see the whole picture, when the Ziegler-Natta catalyst it is performed as granules, which means it was like a little stones. We'll be putting it in here. Yeah, the catalyst will be put in here, and it will be mixed with a liquid hydrocarbon, which is a diluent. And then a mixture of hydrogen and ethene is passed under pressure into the slurry, and the ethene is polymerized to HDPE. The reaction takes place in a large loop reactor, which is this, as you can see, is quite large, with the mixture constantly stirred. On opening a valve, which is here, we could see a valve here, the product is released and collected. The solvent is evaporated to leave the polymer still containing the catalyst. So as we can see, the catalyst is still inside this solvent after it's evaporated to leave the polymer. The water vapor on flowing with nitrogen through the polymer reacts with the catalytic site, destroying the activities as to stop the reaction. So that's all from the slurry process. I'll be going to another process with solution process. It's going to use the Ziegler-Natta catalyst too in this process, but it's more or less the same as the slurry process, which is talked by me just now. So in the solution process, we pass ethene and hydrogen under pressure into a solution of the Ziegler-Natta catalyst in a hydrocarbon C10 or C12. I can prefer which is the hydrocarbon we prefer, and the polymer is obtained in a similar way to the slurry method. So I'm not going to put a picture here, as these two processes are more or less the same, but the most important fact is they too use the Ziegler-Natta catalyst. Yeah. So about the third process, which is the gas phase process, it actually uses a different catalyst. So for your information, it actually doesn't use the Ziegler-Natta catalyst as the previous two. It uses Phillips catalyst, yeah, in a fixed bed reactor. So a mixture of ethene and hydrogen is passed over the catalyst, which is Phillips catalyst, different from the previous two, in a fixed bed reactor. So here, through a bed reactor. Okay, so ethene polymerized to form grains of HDPE suspended in the flowing gas, which pass out of the reactor when the valve is released. So we could see the three of the process that involve a valve. Because we want to collect the product, we have to open the valve and let it flow out. So the most important thing is the role of the catalyst, which is the Ziegler-Natta catalyst in the process. So any question from you guys?
Hello. Sheng. I would like to ask two questions. What is diluent? And for the next question is, what is HDPE?
Okay, thanks for the question, NAUFAL. So about the diluent, it is so it is stated here. It's quite small. I'm going to put it bigger. A diluent is actually a liquid that dilutes the reactants and carries them round. But take note that because we always think that if we put something inside a solution, it will dissolve in it. But that's a completely different case when it comes to diluent. They do not dissolve in it, which differs from the solvent that we used to know. So about the HDPE, which is the short form of high density polyethylene. As you can see, right, it is passed under pressure, so it will form HDPE, which is high density. and the PE means polyethylene. Is that clear, NAUFAL?
Yes, thank you.
Okay,
Thank you, Naufal. Okay, so properties of polymer. Polymer have a low density, which make it easier to lift, have a lack of conductivity for both heat and electrical, and high stiffness. And also, polymer is resistant to corrosion and chemical inertness and transparency. Polymer is high gloss, which it have a smooth surface and it is easy to work. So people can design the polymer as what they want to. So next I will explain about the use of the polypropylene. Who knows polypropylene is a thermoplastic and addition polymer made from the combination of propylene monomers. So this polypropylene is used for packaging, like our plastic bags for if people want to go to buy groceries, so they use plastic bags, and also plastic parts for various industry, including the automotive industry and electrical application. And also, polymer is used for textile and medical industry, and it also used for medical industry because of its properties like high tensile strength, resistant to high temperatures, and corrosion resistance. So, do you guys have questions?
Me, okay. I have a question. Okay. How can polypropylene is suitable for medical application?
Okay. Polypropylene is have a high chemical and bacterial resistance, and also in medical application, they always use disposable syringes of polypropylene. So that's why it's very suitable for medical application. Did I answer your question?
Yes. Thank you.
Okay, so lastly, Shah will continue the presentation.
Okay, now I'm going to proceed to the last subtopic. It is the structure of polypropylene. Okay, actually polypropylene is a tough, rigid and crystalline thermoplastic produced from propylene monomer. It is a linear hydrocarbon resin. So that we can see at the picture, the chemical formula of polypropylene is C3H6. So these days, the polypropylene is made from polymerization of propene monomer. It is an unsaturated organic compound that the chemical formula is C3H6. So when the structure of PP monomer go through the Ziegler-Natta polymerization, it will produce the structure of polypropylene at the right image there. So that is the structure of polypropylene. So upon the polymerization, it can form three basic chain structures depending on the position of the metal groups. So the first one is the atactic, the irregular metal group, CH3 arrangement. The second one is the isotactic, the metal groups arranged on one side of the carbon chain. And the last one is the syndiotactic. It is the alternating metal group CH3 arrangement. So the same as ALIA said, the polypropylene is widely used in various applications due to its good chemical resistance and weightability. That's all from me. Any questions?
I had a question. So what's actually the differences between polypropylene and propylene?
The main difference between polypropylene and propylene is that propylene is a simple molecule, whereas the polypropylene is a giant macromolecule that has gone through the Ziegler-Natta polymerization. That's it, the main difference.
Okay, thank you for the explanation. Shah for expressing her ideas on the structure of polypropylene. So thank you everyone for participating in this discussion and expressing your idea and giving us some knowledge about the titanium 3 chloride as a catalyst. We know all about that. So thank you for listening. Thank you everyone.
Bye.